Imagine trying to translate this really complex, nuanced cultural concept.
Yeah.
Like, say, the difference between an everyday Chinese numeral and a highly secure financial character. And you have to do it using nothing but a single unmarked light switch.
Right, which sounds absolutely impossible.
Yeah. I mean, mechanically, sure, switch works up or down, but the meaning, the actual intent behind it, it's completely lost. And that is the trap of what software engineers actually call boolean-blindness.
Oh, it's such a trap. It's one we fall into constantly, honestly, when we're building these big systems. We try to map the rich, chaotic, real world onto the absolute strictest binary logic possible.
Yes or no?
Exactly. True or false. We boil these incredibly complex domains down to a generic true or false, and in the process, we basically just strip away the actual meaning of what we're trying to communicate in the first place.
Well, welcome to the Deep Dive. Today we're looking at a super fascinating snippet from a blog series by a developer named Ang. Specifically, we're diving into this post called Notes-on-Haskell-Programming, Part 192, which was published on July 21st, 2026.
It's a great read. Really insightful stuff.
It really is. And our mission for you today is to explore this whole concept of Boolean blindness, like examine why it quietly just ruins code bases, and look at the specific programming technique Ang uses to actually cure it at the root.
And we should probably add a quick disclaimer here.
Yeah, absolutely. I want to promise you right up front,
Right.
even if you don't write Haskell or like any code at all for that matter, stick with us because this isn't a deep dive about syntax.
Yeah, not at all.
It's fundamentally about how we communicate complex ideas intentionally and how we avoid making these assumptions that leave our colleagues, completely in the dark.
Because communication is basically the core of software engineering.
Yeah.
I mean, we often forget that the machine, it just executes instructions. It doesn't care about readability.
Right. The computer doesn't care if your code is pretty.
Exactly. The code itself is really a message written for the next human being who has to, open that file and figure out what on earth the previous person was thinking.
Okay, let's unpack this. We need to set the scene a bit with what Ang was actually trying to build here. So Ang has this ongoing project. And the specific goal in this post is writing a function that converts a Gregorian year, like our current year, 2026, into Chinese numeral text.
Which, taking a number like 2026 and translating it into Chinese characters, it sounds like a totally straightforward mapping exercise at first glance.
Right. You just swap the Arabic digits out for Chinese ones and call it a day.
Yeah. But Ang's post highlights this really interesting linguistic catch that completely complicates things. There are actually two entirely different renditions of these numerals that the function needs to handle.
So before we get into the elegant solution for that, we have to look at the trap Ang originally fell into while trying to juggle those two different renditions.
The classic code smell.
Yes. Ang ran right into a classic code smell. And for anyone unfamiliar with that terminology, a code smell is just a great phrase for code that technically functions, like it compiles fine, but it hints at a much deeper underlying design flaw. And the smell here is Boolean blindness.
Yeah, and to really grasp the smell, you have to look at Ang's original draft of the code. So the function was called year to Chinese, and it relied on a single Boolean argument to decide how to translate the year.
A simple true or false.
Right. Ang passed a variable named isFormal into the function. If isFormal evaluated to true, the function output one style of characters, and if it evaluated to false, well, it output the other.
It's basically like, think of a pilot sitting out in a cockpit, and it is filled entirely with unlabeled toggle switches.
That is a terrifying image.
Right. Because mechanically, the switches work perfectly. Push the switch up, the circuit closes, that's your
All right.
Push it down, the circuit opens, that's your false.
But true to what?
Exactly. To what? Without a manual, the pilot is flying completely blind. Does flipping this switch lower the landing gear? Or does it, dump the fuel payload?
But what's fascinating here is how perfectly that analogy captures the day-to-day developer experience. I mean, Booleans strip away all the context at the call site.
The call site being where the code is actually used.
Right. So imagine you're another developer joining Ang's team, or even just Ang reading this code 6 months from now. You open a file, and you see a line executing a command. Year to Chinese, true, 2026.
And the machine executes it flawlessly.
It does. But to the human reader, that random true conveys absolutely zero intent.
It's just an unmarked switch pushed to the up position.
Exactly. Does true mean use the traditional lunar calendar instead of Gregorian?
Oh, that's a good point.
Or does it mean append the character for year at the end of the string? Or does it mean the year happens to be a leap year? You are completely blind to the meaning.
So what do? You just have to guess.
No, you can't guess. To figure it out, you're forced to stop what you're doing, totally abandon the piece of code you were trying to understand, and go dig through the internal logic of that year toddy's function, just to map that single toggle switch back to reality.
Which completely breaks a developer's flow state. Like you're holding this massive, fragile mental model of the software in your head, and suddenly you have to drop all of it just to decipher the basic vocabulary of the program.
Yeah, it demands a massive amount of unnecessary cognitive load.
I can imagine.
And you multiply that cognitive load across hundreds of files, thousands of lines of code, and dozens of these unlabeled toggle switches scattered everywhere.
It just sounds exhausting.
It really is. You end up with a code base that is just exhausting to read and incredibly dangerous to modify. I mean, it becomes inevitable that someone eventually is going to flip the wrong switch.
So let's apply this abstract danger directly to the real-world use case Ang was trying to solve. Let's dig into translating the year 2026 and the actual nuances of these written Chinese numerals. We mentioned earlier that Ang needs to generate two distinct styles.
Right, and the source material gives us the exact breakdown of these two styles. So the default case, which Ang initially mapped to the is formal switch being false, is the simplified or regular case.
Okay, so in this simplified case, the year 2026 translates to regular everyday digits. So 2, 0, 2, 6 becomes earling, early-u. It's a very direct translation that you'd use in daily life.
Exactly. But the other side of that toggle handles a much more complex requirement. When isFormal evaluates to true, the function outputs formal digits, which the source specifically notes as financial digits.
So 2026 becomes a completely different set of characters.
Yes. Visually, they are much denser.
Right, those characters are super intricate.
Visually denser and, crucially, historically vital. Like, the everyday simplified character for the number 2 is literally just 2 horizontal lines.
Super easy to write.
It takes a fraction of a second, but if you're writing a bank draft for $20,000, 2 horizontal lines are incredibly easy to forge.
Oh, wow. I didn't even think about that. You just add a stroke with a pen, and suddenly the amount changes.
Precisely. The formal version of 2 has multiple intersecting strokes, making that kind of casual alteration basically impossible.
So Ang really needed this function to reliably toggle between these quick everyday characters and the highly secure formal ones.
Exactly.
Okay, I'm going to push back here for a second, though, because looking at this specific problem, we have two distinct options: everyday simplified characters or formal financial characters.
Right.
That's a strict binary. It's an either-or situation. So why is a true-false toggle actually a bad architectural choice here? Like, it seems to me like the exact scenario a Boolean was invented for.
And, you know, the intuition to use a Boolean makes total sense at first glance, which is exactly why boolean-blindness is such an insidious trap.
It tricks you.
It completely tricks you. But look closer at what the code actually communicated.
Okay.
Ang used a standard conditional statement. If it's formal, then formal digit map, else regular digit map.
Okay, so if true, do formal, else do regular.
Right. But structuring it that way forces the entire system to treat the simplified style as merely the absence of formal.
Oh, I see.
Yeah. Tying the logic to true and false inherently prioritizes one state over the other. Formal is elevated to a positive state. It is true.
And simplified is just whatever is left over.
Exactly. It's demoted to a default negative. It is merely false. But in the real world of linguistics and culture, simplified isn't just a lack of formality.
Right, it's its own thing entirely.
It's its own distinct, perfectly valid category. By using a Boolean, Ang essentially hid the actual vocabulary of the domain, these rich cultural concepts of simplified versus formal, behind just generic structural logic.
You're taking these really specific cultural and linguistic concepts and you're just flattening them into a generic yes-no question. It's like that's looking at a traffic light and asking, is the light red? False.
That's a great way to put it.
Okay, well, is it green or is it yellow? False. Doesn't actually tell me what state the world is in. It only tells me what state it isn't in.
Exactly. When you're communicating complex logic to a teammate, you don't want them doing mental gymnastics to figure out what a false state implies by process of elimination. You want to hand them the exact vocabulary word for what is happening.
So if boiling this down to a generic false destroys the linguistic meaning, how does a language like Haskell actually allow you to preserve that meaning in the code? Because Ang decides to step back and rewrite the code using a much better structure to cure this Boolean blindness.
Right, and Haskell, along with a lot of modern type languages, offers a beautifully elegant mechanism for this exact scenario.
So if a Boolean is out, Ang must be forcing the program to accept a totally custom data type, like Ang throws out the Boolean entirely. No more is formal. No more true or false.
None of it.
Instead, the solution relies on something called a sum type. And just to orient anyone coming from other programming languages, Ang notes that a sum type is typically known as an enum, or an enumerated type.
Yeah, a sum type allows you to basically tell the compiler, hey, I'm creating a brand new category of data, and here is the exhaustive list of every possible value it can ever take.
So you're making the rules.
You define your own custom universe of options, rather than relying on that generic universe of true and false.
Let's look at the exact data structure Ang created then.
Yeah.
Because it's incredibly concise. Ang literally just writes data numeral style, simplified formal. And that vertical bar is just syntax for or.
Right.
So a numeral style is either simplified or it is formal.
And that single line of code changes the entire foundation of how the program operates.
Really? Just that one line?
Absolutely. Because once you define that sum type, the function signature itself, like the physical description of what the year-2 Chinese function expects as input, changes permanently.
So the old function signature effectively said, I take a Boolean and an integer, and I return text.
Right. But the new function signature says, I take a numeral style and an integer, and I return text.
Oh, wow.
You literally cannot pass a generic true or false into this function anymore. The compiler will reject it immediately. You must pass either the exact word simplified or the exact word formal.
Okay, here's where it gets really interesting. Going back to our cockpit analogy from earlier.
With the unlabeled switches.
Yeah. So instead of using that unmarked toggle switch where up is true and down is false, we've basically ripped that switch entirely out of the dashboard.
Gone.
And in its place, we've installed a custom specialized dial that has exactly 2 settings, and it has clear, permanently printed labels right on the hardware. One says simplified, and the other says formal.
That tiny shift perfectly aligns the underlying code with actual human language. You bring the vocabulary of the problem space directly into the solution space.
You no longer have to translate your human intent into machine logic. The machine logic has adapted to your human intent.
It's brilliant. But, the benefits go far beyond just having readable labels.
There's more.
Oh, yeah. Defining the sum type is only half the battle. We have to look at how Ang actually implemented this new dial inside the function and why this profoundly impacts a team's workflow and their bug rate.
Okay, so Ang has to rewrite the internal logic that actually decides which characters to pull from the database.
Exactly. Ang replaces the old if-then-else statement entirely. So it used to be, if is formal, then formal digit map, else regular digit map.
Right, the yes-no question.
That gets swapped out for a case style of block.
A case statement.
Yes. So the code now essentially says, look at the numeral style that was provided. In the case that it is simplified, use the regular digit map. In the case that it is formal, use the formal digit map.
It explicitly pulls from the appropriate map based on the exact name of the style provided. So what does this all mean? Like, why go through the effort of refactoring a function that was technically already doing the math correctly? If you're managing a team of developers right now, you might be thinking, why does this linguistic nuance matter if the code passes the test suite?
That's a fair question.
But Ang gives us the ultimate conclusion right at the end of the post. After this refactoring, Ang writes that the code is basically self-documenting and far more readable.
And self-documenting is really the holy grail of software engineering.
That's what everyone wants.
Exactly. It means you don't need to write a massive manual or rely on these clunky comment blocks that instantly become outdated the second someone changes the code, just to explain what the function does.
The words used in the code itself explain exactly what is happening.
Yes. When a developer sees year-2 Chinese formal 2026 written in the codebase, there is zero ambiguity. You know instantly, without ever tracing the underlying function, exactly what output is being requested.
The cognitive load just vanishes.
Completely. And furthermore, using a case statement with a sum type provides a mechanical safety net called exhaustiveness checking.
Exhaustiveness checking. That sounds intense.
If we connect this to the bigger picture, think about what happens if the requirements change.
Which they always do.
Always. Suppose 6 months from now, a product manager comes in and says, hey, we also need to support an ancient historical style of numerals.
Okay, so a third option.
Right. If Ang had used a Boolean, expanding from 2 options to 3 becomes a messy nightmare of nested if statements. Or you have to change the data type entirely, which, usually introduces a ton of bugs.
Because a Boolean physically cannot hold 3 states.
Yeah.
It's mathematically impossible.
Exactly. But with a sum type, Ang simply updates the definition. data numeral style, simplified, formal, historical. And here is the real magic. The moment Ang does that, the compiler will scan the entire code base and actually throw an error at that case statement we just talked
Oh,
about.
because the case statement is missing the new option.
Yes, the compiler literally says, wait a minute, you told me what to do for simplified, and you told me what to do for formal, but you haven't handled the case for historical.
So the code literally refuses to compile until you explicitly address the new category. It won't even let you break it.
The compiler acts as an automated guardrail. It forces the developer to handle every single possible reality in the universe they just defined.
That is incredibly cool.
You just can't achieve that level of automated safety when you're just checking if a generic Boolean happens to be true or false.
Right. Good code isn't just written for machines to execute. It's primarily written for humans to read, safely maintain, and scale up over time.
Exactly. The machine doesn't care if you use Booleans or sum types, or if you name all your variables with random strings of letters like X and Y. The machine compiles it down to ones and zeros regardless.
Right. The structure is entirely for our benefit.
Eliminating Boolean blindness highlights this really important shift in how we think about problem solving. When you rely on defaults like, treating simplified as just the false state of formal, you're letting the limitations of generic binary logic dictate how you model the real world.
You're squishing the real world to fit the code.
Exactly. But some types force you to respect the domain you're working in. They force you to name things accurately.
It's about giving every distinct concept its proper noun. It's such a small mechanical change in the syntax, but conceptually, it's night and day.
It totally bridges the gap between how humans think in categories and labels and specific contexts, and how the machine processes instructions. By choosing a sum type, Ang essentially taught the compiler a little bit of human linguistics.
Well, we've covered a lot of ground today, and I really want to thank you for joining us on this deep dive into the elegant logic of Haskell programming and into Ang's excellent blog post.
It really is a fantastic example.
It perfectly demonstrates how replacing generic defaults, like our blind toggle switches, are Booleans with highly specific language, like our labeled dials, our sum types, instantly creates clarity out of confusion.
And clarity is always a choice we make in how we design our systems.
But before we leave you today, we want to zoom out even further.
Yeah, because this whole discussion raises a super important question that goes way beyond just programming. If avoiding binary Booleans in our code forces us to name our intentions explicitly and forces us to recognize distinct categories instead of just defaulting to true and false.
Which is a very profound thought.
Right. How many other so-called binary choices in our daily logic, our arguments, or our lives are actually hiding much richer, specific categories? Categories that desperately deserve their own names rather than just being defined as the opposite of something else.
Are you navigating your life reading clearly labeled dials? Or are you just sitting in the dark, flipping an unmarked toggle switch and hoping for the best?
Honestly, it's something to think about.
Definitely something to think about the next time you're forced into a simple yes or no. Thanks for listening, and we'll see you on the next deep dive.